So right there is my 500-foot coil on the beam. So I'm thinking I need to add a feedback coil to it. What's a feedback coil, you ask, and what do I plan to do with it? Here, I'll show you. So right here in this flyback circuit, you can see the feedback coil right here. The feedback coil just basically comes down here and turns this transistor on and off. How this circuit works, you have your positive power coming in here. When this transistor fires, current surges through this coil, causing a power surge in the high voltage coil here. And this feedback coil that you see right here just keeps the transistor turning on and off. You also have your feedback resistors controlling the amount of current going into the transistor and feedback coil. So I was thinking, could I add a feedback coil to the coil that's already onto the beam and somehow pull even more power out of it? I mean, there's got to be something I can do. And I can take two diodes and turn them into a transistor. Here, I'll show you how I do that. Right here you have your PNP transistor with your arrow pointing in. You got your base, collector, and your emitter. The emitter is always the part with the arrow. And right here you can see your NPN transistor with the arrow not pointing in. That's how you remember it. The arrow's not pointing in, NPN. You got your base, collector, and your emitter. Anyway, these transistors are made out of N-type material and P-type material. And a diode also consists of N-type and P-type material. You got your positive side of the diode being the N-type, and your negative side of the diode being the P-type material. So to make a PNP transistor out of two diodes, you just take two diodes and face them towards each other like this. You can see that one, you can see this one facing towards each other. Emitter, collector, base. Here you can see the NPN type transistor made out of two diodes that are facing away from each other, not pointing in. You got your emitter, your base, and your collector. All you do is just take the proper diodes for the proper application and put them together. The circuit isn't right, and you can see the meter right here. That's not exactly the right kind of circuit for this. I'm going to have to reverse engineer it and flip-flop it around. Yeah, I'm wondering if I can get it to pull energy out of the air better than my 500-foot loop antenna that's outside. Yeah, everyone knows about audio feedback. You take a microphone, you stick it in front of the speaker, and you get that horrendous screech. It sounds like a train whistle. I'm hoping I can get that feedback coil to work like that. But instead of that horrendous screech, I'll get more power. Yeah, any magnetic field in the air is going to be induced into that iron beam. For the next experiment, I'm going to take the 500 feet of wire off the beam, painstakingly coiling it up. And when I have it completely off the beam, I'm going to take it to one end, and I'm going to count every single space on that beam where I can put wire. I'm also going to count the amount of turns in the current coil. And I'm going to try to put an even amount of turns on the beam every place I can, the whole way to the other end. And we'll just see what that does. Oh, thanks for watching. Please subscribe. Stay tuned.